Hey there, Math 1 students. So in this particular video, we are going to be looking at reviewing our exponential function unit for our EOC. So let's go ahead and take a look at this. So number one, the function, which it says f of x, but let's remember that is the same thing of saying y is equal to 2 times 2 to the x power, okay? So that was replaced with f of x plus k. So what it's saying is this right here currently is f of x, or y equals. It's going to be replaced with adding k to it. So it would be 2 times 2 to the x power, and then we're going to add k to that. Okay, resulting in the function graphed below. So this part right here is already graphed for us. Okay, and it's asking us what is the value of k. So let's kind of dive in and remember our exponential function formula. So we can use f of x or y is equal to, either is the same, and then it was a times bx. So a was our y-intercept, okay, and then b was that ratio, or what it was being multiplied, that common ratio, instead of like the common difference, which would be in a linear function. So our y-intercept was what was being multiplied, and if we're going to be adding something to it now, that's also going to be affecting our y-intercept. And so what happened was it went from the 2 times 2 to the x power, and then whenever we added k to it, whatever k was, we had a graph, and it started out right here with the y-intercept being 2, because it was 2 times 2x, and now we're adding something to it. Okay, so this 2 started off being our y-intercept, and then whenever whatever k is, because they're not telling us, if we replace that with plus k, whatever that value was, it shifted the graph down 1, 2, 3, 4, 5. So what is the value of k? -5. Because now my y-intercept is down there at -3. So what was added to it was -5, because it affected the graph by bringing it down to -3. So I'm going to bubble in -5. Okay, so let's go ahead and take a look at number 2. So Monica did an experiment to compare two methods of warming an object. The results are shown below. So method 1 is in that very first column. Method 2 is in the second. So let's go ahead and look at method 1. So method 1, we are increasing, I believe. Let's figure this part out. So in number 1, we are going plus 5 plus 6 plus 4 plus 4 plus 6. Okay, so that's the difference there and what you're adding. Okay, so is it a constant rate? Not so much, but we're not multiplying. We're adding there. So I'm going to mark adding here. Okay, now let's look at the other one. We go from 1.5 to 3. That's a decimal, not as clear, so let's look at the whole numbers. 2 to 6. Okay, I could add 3, but 6 to 12, if I add 3, doesn't work. 12 to 24, 12 to 48. Something else is happening here. We're multiplying by 2. And you also multiply by 2 to go from 1.5 to 3. Okay, so which statement best describes these results? So the temperature using both methods changed at a constant rate. So that's not true, because the first one definitely was not constant. Constant would be the same rate, and so that is not true. The temperature using both methods changed exponentially. Not true, because method number 1 here is adding. The temperature using method 2 changed at a constant rate. Yes, it was constant, but a constant rate means that you're adding the same number. So not true. And then option D, the temperature using method to change exponentially. That is true because we are multiplying. So if something is multiplying, is doubling very fast. In this case, because we're multiplying by 2, so that will be represented by an exponential function. Okay, diving into the next questions, we have the value of an antique car is modeled by the function v of x, which we can just go ahead and say is y, is the price of the car, because that was your initial, remember that's your y-intercept, what is being multiplied there out front, 107,000 times 1.09, and then we have 2/3 to the x power. And my question, when I get down there, by what approximate percent rate is the value of the car increasing per year? So let's recall the percent rate, or the general equation there that we use is y is equal to a times, was this one, antique car, so it's probably increasing. Yeah, because this right here is greater than 1. Okay, and then we had it by t, which was our time. Okay, something to note, up here in our equation that was given, it has 2x, 2/3 x. Okay, so that is a little different from what we've seen, because there's not just an x, or there's not just a t there for time or a number. Okay, so it has two parts together. So this one just gets a little bit complicated before we really dive in and find that percent, because your go-to to find the percent would be like, oh, I'm going to take 1, I'm going to subtract this decimal here, so it's 0.9%. Because it would be 0.009, you would move that decimal point 2 times and get 0.9. Luckily, that's not a particular answer here, because that would be a most common mistake, because what they don't necessarily want you to see is that 2/3 times the x power. It gets a little trickier there. So let's kind of break apart. If you remember your power law, when you're dealing with exponents, so you have a base, and let's say I had the power of 2 raised to the 4th power. Okay, what would you do with those two numbers? Remember, you would multiply those, and you would get x to the 8. So that's kind of what's happening here. They went ahead and multiplied that 2/3 there by the x. So let's go ahead and break it down, break it back apart necessarily. So we have y is equal to 107,000 times 1.009, 2/3, and then let's put the x for time back out there. Okay, so now we have a little bit of math to do to find the actual percent, and the actual number that is in here. So we're going to take 1.009 and multiply, or raise that, to the 2/3 power, and then get that decimal. Okay, I'm going to switch out and grab, because it is calculator active, the decimals calculator to solve this problem, and then I will be right back. Okay, when I put it into my decimals calculator, I got the number 1.0059. Let's go ahead and round that to 1.006. Okay, so what is that percent? Remember, if I take 1, subtract, or 1.006 in this case, and subtract 1. Okay, now that's a decimal. Changing it to percent, I need to move that decimal 2 times. So it'd be 0.6%, or 0.6V. Okay, so C would be your correct answer there. Go ahead and clear this part off so I have room to write there in the next one. Okay, So kind of the same concept. I have some fractions popping up here in my exponent laws. So let's look at this one. So we have x 1/3 to the negative third. Okay, so this now is your base, the whole set, and with our power law, or power to a power, we took 1/3, we took our exponents, and we multiplied them together. So we do 1/3 times -3. So I'm going to break out here and kind of show that works. So 1/3 times -3, let's go ahead and put that over 1. We would get -3 over 3, which is equal to -1. So our exponent then would be -1. So x raised to the -1st power. Okay, let's also remember our negative exponent law. So that's when we ended up dividing because we are creating fractions in a sense. So my new result, or my new answer, final answer, would be 1 over x. Okay, number 5 is also throwing those fractions in there with those exponents, just to make sure that we are making sure that we hit everything that could be on your EOC. Okay, so let's go ahead and look at number 5 there with all these fractions, and we also have exponents inside of the parentheses and outside. So that means it's that wonderful power to a power law again. So this 2/3 is going to go to every single thing on the inside. Okay, so we're going to have 16 to the 3/2 power. We're going to have x is going to end up being multiplied by, 3/2. Okay, then we're going to have y to the -2nd multiplied by 3/2 all over x to the -1/6 times 3/2, and then y to the 6th power times 3/2. Okay, so if this was calculator active, I'll be plugging in the calculator there to multiply those decimals out, those fractions out. And then also, if it wasn't, I'll be going off to the side and doing 1 over 6 times 3/2. That would give me 3/12. Okay. So 16 3/2. I'm going to leave that there just for a second. So then we would have x to the 3/12 power. Okay. And then we have -2 times 3/2. And that gives us -6/2, which would be -3. Okay, now let's remember we cannot have negative exponents. Okay, so I'm going to go ahead and write that one down on the bottom and change that to y/3 because it was originally up here on top. So that negative right there was on top, and so I just moved it down to the bottom. Okay, now we have x to the -1/6 times 3/2. I'm working on this one right here. So -3/12, which simplifies down. Make sure I did it right. -3. Okay. Okay, so that was negative, and it was located right here on the bottom. So I'm going to go ahead and move it up to the top. And as I'm moving it, I also noticed that this one right here, right beside it, is in 3/12, and that's what I got right here. So I'm just going to go ahead and write it back to the non-simplified form and put 3/12. And then we have one more down here to do, and that's going to be 6 times 3/2. 6 times 3 is 18. Divided by 2 will give us 9, and that was positive, so it's going to stay where it's at. Okay, that was a lot. Let's combine up those like terms. So we have, let's look at here with the x's. Okay, so we have x right here that we can combine, and so bases are the same. So we can add those straight across there. So 3 plus 3 is 6. Over 12 will reduce down to 1/2. Okay, do you see an x to the 1/2 power? Okay, I see one here and here. And then on the very bottom, I have 3 plus 9, which would give me y to the 12th power. So it's looking like D is the correct answer. And as you see, I didn't even have to do 16 to the 2/3 power because I was able to figure out everything else. And then that was my only option there that it could be with the correct exponents that I had. Okay, I know it's a lot. Keep chugging away here with me. So number 6, the value v of a car can be modeled by the function v times t. Let's just go ahead and call that y is equal to 13,000 times 0.82 times, or raised to the t power. Okay, so first thing I see is thank goodness we don't have a fraction hanging out. We have nothing hanging out over here with the t where we need to remember our exponent laws. So we're just good to go with the normal way to solve an exponential growth or decay problem. Okay, so let's talk about the value of the car. T with the number of years since it was purchased. To the nearest 0.1%, what is the monthly rate of depreciation? So we know that this car is decreasing because, well, one, the question said that. And then also something to note was that this percent right here is less than 1. So when that happens, remember your car is depreciating or it's declining exponentially. So it was y is equal to a. Remember that's your y-intercept or your initial amount of money. 1 minus r to the t power. Okay, so we have that 0.82 in there. Okay, so what we need to do is we need to take 1, subtract that. Well, actually it equals 0.8, so just kidding. So technically it is 1 minus r is equal to 0.82, if you remember that piece there. So you would end up subtracting and subtracting there to solve for your r value, but there was a shortcut, which we're going to get to in just a second. And then you could divide by 1 and divide by 1. But your shortcut there is just taking 1 minus 0.82 and working in the opposite way to get 0.18. Okay, so now that is in decimal form. And the percents are, we need to go from a decimal 2% by moving that or moving your decimal point twice or multiplying by 100. And so your correct percent there would be D. Okay, we just have a couple more here to go through. And so let's take a look at number 7. Okay, taking a look here at number 7. The current student population of Brentwood Student Center in 2000, the enrollment at the center increases at the rate of 4% in each year. To the nearest whole number, what will be the student population closest to in 3 years? So, couple keywords is we know that it is increasing, so that's going to be an exponential growth. Okay, and I knew it was exponential because it said the rate of 4%. Okay, so what is the initial? So it started out at 2,000. Okay, then we did times. It was increasing. Let's do 1 plus, changing 4% to a decimal. We 0.04. And then T is your time, and that was 3 years. So luckily, this is calculator active. So you can go ahead and plug those away there into your calculator. And when we do so, we get about, so it kind of rounds up. I'm going to use the squiggly instead of the equal sign just to represent about 2,250, and that would be choice B, or the number 2 there. Okay, so next we have Mr. Smith, who invested $2,500 into a savings account that earns 3% interest. So earning would be it's increasing. They gave us a percent, so I also know it's exponential, and it's compounded annually. He made no additional deposits or withdrawals, which expression can be used to determine the number of dollars in his account at the end of 4 years. Okay, so something to kind of pay attention to was it's compounded annually. That's good to know because if it said monthly, I would have to change these years into months. Okay, but it says annually. What it told us about the time matches. So years and years it matches. Great to know, so we don't have to do any more calculations there. Okay, so we have 2,500. That was the start, the initial, the y-intercept. It was increasing. I'm going to go ahead and change that 3% into a decimal. And it was 3 years. Okay, it is calculator active, so plug and chug away there, and oops, it was 4 years. Plug and chug away there to get that answer. Or if we're taking a look and checking out our multiple choices there, it wasn't even asking for a full-on answer, it just wanted the equation, which expression could be used. And so let's just be careful here. Awesome, none of the choices in there already added the rates. They're together to 1, so we start off with 2,500, that's in all of them. 1 plus 0.03. Ooh, some of these tried to get us there with the way that we changed the percent to a decimal. And then also the other ones try to get us there where we put the rate and the time. But the time was 4 years. So that option there would be A. Okay, now we have some simplifying expressions here with some radicals. So we didn't necessarily get into it just because of time there with Math 1. But if I had, let's say, like the square root of 9, we know it is the inverse operation of squaring something. So yes, the answer there would be 3. But really what's happening, in a sense, is you're taking everything and you're raising it to a particular power. So if you have a square root, okay, that power is 1/2 technically. And then if you have a cube root, that's to the 1/3 power. Okay, you're going to see it work out in this one. So just bear with me here in just a moment. Okay. And remember, it's to the 1/2 power, not taking the 1/2, or not dividing something by 2 or taking it by half. You're raising it to that particular exponent, or you're raising it to the 1/3 exponent and not dividing it by 3. Those are two different things in both cases, unless the base is 2. But anyways, so we are going to really take care of this to the third, or the cube root, which is going to be raising something to the 1/3 power. So we have 8 to the 1/3 power. We're going to have x 2 times 1/3. We're going to have y to the 3rd power times 1/3. And then z to the 4th power times 1/3. Okay? So we would have 8 to the 1/3 power, which I'm going to leave that again just in case, like, it's calculator inactive, although there's a calculator up there, so we're kind of good to go. But just in case, I wanted to show you if we simplify the other ones, sometimes we don't need to worry about raising anything to a fraction power. So we would have x, and if I do 2 times 1/3, I'm going to get 2/3. For y, 3 times 1/3, I'm just going to get 1. And then z would be 4/3. Okay, so which one of these has x to the 2/3 power, z to the first, y to the first, and then z to the 4/3 power? That would be B. So I didn't even need to worry about that 8 to the 1/3 power there, because I was able to use process of elimination. But 8 to the 1/3 power is 2. Okay, number 10. The table below shows the average rate of the type of plankton after several weeks. What is the average rate of change in weight in the plankton from week 8 to week 12? Okay, so some keywords here that I see is in my answer choices is talking about per week, per week, per week, per week. And those were keywords for slope. Okay, so this one right here is a linear change. okay, which means the rate of change was the y minus y over x minus x, or the rise up, run out. And so the other part of this question was asking what is the average rate of change in plankton from week 8 to week 12. So let's take a look at 8 weeks values and weeks 12 values to find that average rate. Okay, so my y values are 0.49 and 0.04 over 12 minus 8. And again, calculator active section. But that's going to give me 0.45. This is going to give me 4. And when I divide those, my m, which is my variable that stands for slope, is 0.1125. So that would be answer choice D. Okay, last one to go for exponential review. Okay, Trina has a college fund started with a deposit of $10,000. So that's what we're starting with. That's our y-intercept, or our initial amount of money, which earns 5% annually. Okay, again, I'm just going to underline that word because that's something that we're going to need to look at there when we talk about time, or possibly need to work out. If no other monies are deposited, how much money will Trina have in her fund at the end of 3 years? Whew, awesome. So it said compounded annually, and my time that it's talking about down there is in years. So we're good. No other extra calculations need to happen. And it's talking about earnings, so we know it's increasing. So 1 plus. I need to change 5% here into a decimal. So 0.05, and then in 3 years. So whenever you place that into your Desmos calculator, we're going to get 11,576.25. And so that is your amount of money. And that is option 2 or option B, whichever way you want to look at it, there on number 11. So this was just the start here of reviewing for our EOCs and taking a look at exponential functions in this particular video.